Good morning, everyone. I'm Sharon Bowman, Editorial Director of ISE Magazine, and welcome to the second day of ISE Expo. In a moment, we're going to start our tech talks, but first, I want to tell you the topics that they're going to be speaking on. The first topic is network engineering in the age of digital transformation. The second topic is transforming access with NG-PON2. And the third topic is the evolution of dynamic networks. During each presentation, we want you to get involved. So you'll see on the big screens a number that you can call to send us text questions. Please note who you're sending them to, and you'll get to know these guys in a few minutes. But we will take them at the very end and do our best to answer all of them, if not most of them. And with that, let's get started. Our first topic is network engineering in the age of digital transformation, and I'd like to introduce Ken Paker.
Ken joined TDS Telecom in 1996. He was named Vice President of Network Services in 2006 and CTO in 2014. In 2018, he was appointed SVP. In his current role, Ken leads the Networking Services and Information Technology departments. In this capacity, Ken has responsibility for guiding new product technology and presides over the architectural direction of the company's network. He oversees the delivery of software and infrastructure projects across diverse, state-of-the-art technologies, as well as the company's mission-critical IT applications and services. He also directs the planning, engineering, and building of TDS's networks to ensure customers have access to the most reliable internet, phone, and TV services. Ken earned a Bachelor of Science in Computer Science and Biology from Purdue University, a Master of Science in Computer Science from the University of Southern California, and a Master of Business Administration from the University of Wisconsin-Madison.
All right. Good morning, everybody. Good morning. So I could have subtitled this talk, Can Old Dogs Learn New Tricks? Because I've been in the industry for 38 years now, and kind of what I wanted to talk about was really the transformation that's been going on at TDS the last 3 to 5 years around how we're using data analytics to take some pretty classic planning and engineering processes and kind of re-engineer them and elevate them to 2018 standards, so to speak. So this is, we are a public company, and this will, I promise, be the last safe harbor statement you see today. And I'm going to spend the next 10 minutes reading everything on here. Not really. What this basically says is he could just be making all this up. So anyway, TDS is a company that we're very diverse geographically. So we literally are a service provider in more than 30 states. We have ILECs, we have cable companies, we have CLEC networks. So large portfolio of options, if you will, in how we do network deployments. And this plays very heavily into how we view the world and kind of how our processes have evolved over time, because we still have centralized engineering for the most part. And so we have to be able to project that image, if you will, across a very broad geography. And one of the things that the data analytics is helping with is our ability to do that. So really what you're talking about here is the cross-section of two classic processes. The first one, we all know, it's network planning, then move to engineering, then move to construction. That's what, you know, the telecom engineers, how they view the world. The data scientist views the world in this pink bar here on the bottom. It's like, how do you take massive amounts of data, turn that into information, and then turn that into knowledge? If we were really, really good at that, we'd have wisdom on the other end of knowledge here, but that's still aspirational at this point. But what we're talking about now is data sources from all different kinds. So, you know, we all began our careers, and what does everybody do in our companies? We all complain about, well, those records are wrong, and, you know, so we've had a long history of trying to keep up with records, right? And so on one hand, you would think, well, this is going to make the problem even worse, but I would maintain that it's actually better, because what we're doing is we're taking our internal data sources and we're combining that with external data sources. And the combination of those two things is where the power is derived from this. So from external sources, we're taking parcel data as an example, and we're overlaying that on top of our spatial GIS data and where our outside plant is today. And there's all kinds of new inferences you can make when you start to see these things together. And so this is just a trend that just keeps going on and on and on, if you will. So let me just talk about how we go through these processes and then what analytics are doing inside each of these processes. So the first one is really network planning. Now, network planning has always been a function where you've kind of gotten as much data as you can get on any given geography, and then you weave that into designs. And what's different now about this is that we can do a lot of semi-automated designs. So for our ACAM program, as an example, we have literally hundreds and thousands of projects that we have to be able to plan and engineer in order for that program to be rolled out. And in the old days, we would have literally almost started with a blank sheet of paper, if you will, on every exchange and every DSA. In today's world, you start with the external data in our GIS renderings of this, and we can actually do semi-automated designs on how much fiber do we think we're going to need to deploy, where should new DSAs go, et cetera. And what's really cool about this is that whereas before, to make a change in a parameter, you would have to essentially start all over with the design. In this scenario, you can change parameters and essentially have the analytics engines do the work for you. And so we can do a lot more scenario playing now and planning than we ever were able to do before. And this saves the company a ton of money at the end of the day, because you can spin all kinds of scenarios and quite honestly, reverse engineer the economics of what we are deploying. So this is one of the things that we did on ACAM in particular. We've basically reversed engineered, we need something that does this in order to be able to get to that economics. And as an example, for us, our ACAM program has a lot of copper deployments, and so we were initially planning to just do what we had always done with copper. And in fact, what we ended up doing because of this work, we completely rejetted the program into vectoring and basically making the copper sweat as much as possible, and it literally was worth a ton of money. We never could have been able to do that without this iterative planning process. So next I'll move on to engineering. Now this one's a little more, I guess, realistic and I think more reachable, if you will, because what we're able to do in this part of the process is essentially keep better track of what's going on with POs, logistics, the whole life cycle of how equipment and or pieces and construction efforts go together to make these overall projects complete. And this goes end to end. And so the goal here is to keep everything electronic. So whenever we have to reduce things to paper, and that's kind of the classic way that this used to work, right? We literally print tons of paper that would be rolled up and thrown in the back of a truck. Our ultimate goal is to keep this as electronic as possible, and that also brings cost out of the system. And finally, we get to construction. And this is where, when I talked about the geographical dispersion part for TDS, this is where this has a big impact on us, because we're able to now take real-time data pretty much on a daily basis, and at any given point in time, we have a very current, if you will, as-built process. So whereas before, in the old paper world, you'd be redlining paper and maybe months later it'd end up in a record system. In some cases, this is happening in daily or in near real time. Very important for us to be able to track the progress of all these thousands of projects. So what I wanted to really, though, leave you with is the notion about some of the culture changes that are required and for this to really be successful in your organizations. And the first one is really getting people comfortable about transparency. When you get into these data analytic scenarios, it often looks to workers like this big brother looking over their shoulder. And so it feels a little uncomfortable at the beginning. But the backside of this is very important because, in essence, you're making everybody in the organization smarter now by actually having this analytics feed back into their thought processes and to their decision making. And so you have to get over that hump to sort of start recognizing those benefits, and the benefits actually accrue to each individual in addition to the company itself. The other thing that I would say is And I think, well, at least at TDS, we don't fear change very much. I mean, we're constantly trying to push the envelope in terms of where we're going. But the potential that we have in analytics is just absolutely phenomenal. There's no end in sight, I guess, to where I'm viewing the potential of how we can improve processes and further drive optimization in the network. But as you all know, and as I referenced earlier, data integrity is very, very important, and we can't underestimate that. And so we can take the analytics to help improve the data quality. We can do a lot to fix processes that have, at the very beginning of them, lots of check work on whether or not the data is accurate. So the other thing, the second big category is to really expect significant improvements. So we kind of dabbled in this for a while, and then we kind of launched a rather significant business case with our executive team and kind of said, you know, we're going to bite the bullet. We think that there's this kind of potential, and we're going to commit to these kinds of savings. And I would tell you that every time we've gone down one of these initiatives, we've underestimated the benefits. Costs, we were pretty much right on, but the benefits were always stronger than where we started out, and that's very, very important. The other thing that I would tell you is don't just think about how you can optimize the engineering part of the organization, because this does ripple into the marketing organizations and to finance and to all the other various functional units within our companies. And then the final big point, I guess I would say, is the more new and unique combinations of data that you can make, the more mashups you can make with this data, the better the benefits are going to be. So, you know, the benefits come when you take two universes of data and you put them together and draw new insights that you quite honestly couldn't get to before. And that's a very, very big deal. So with that, thank you very much. I appreciate your attention, and you know, be sure to text questions in for us later. So thanks.
Thank you so much, Ken. Yes, do send questions to Ken, and our next presenters from Verizon are going to be talking about transforming access with NG-PON 2.
As Vice President of Network Planning, Lee is responsible for developing core network elements, platform technology, and future roadmaps to meet Verizon's long-term infrastructure requirements. Prior to his current position as Vice President of Global Network Engineering, Lee was responsible for engineering and implementation of wireline networks that support consumer, enterprise, and wholesale video, data, and voice services. He also was responsible for video operations that support broadcast and on-demand video content acquisition, transformation, grooming, delivery, and ad insertion. Brian's responsibilities include managing network reliability programs, new technology, and service validation and deployment, as well as post-deployment vendor management for all consumer, enterprise, and wholesale network services. He's also responsible for power, HVAC capacity engineering, and construction of global central offices and data centers.
There's something that's easy to forget. Something that goes to the core of who we are. There's no this without this. No this without that. No AR, VR, AI, IoT, holograms, self-driving cars, or whatever it is that comes next. None of it without the network that comes next. That's why we're building this. Know how to build next-gen, 2G, 3G, FiOS, 4G LTE, LTE Advanced, 5G, and now, Intelligent Edge Network. So while everyone is talking about the incredible opportunities of the future, this, and even that, especially that, we're actually building the platform the future runs on.
Morning, everybody. That video is really appropriate, I think, especially for this show. This is one of my favorite shows, and I like it because it's the things that you can touch in the network. Cable, tools, the part of the network that is the most real. In fact, Brian, you had a quote this morning at breakfast. What did you call it?
I said it's the stuff that you cannot ever virtualize.
Yeah. So we really appreciate the folks in this room and all the work that you do to help Verizon and all the carriers actually help create the future. And along those lines, we wanted to talk to you this morning about work that's going on in Verizon in our next generation of fiber access. And as we look at what we need to do to put in that next-gen network, we start with fiber. As you know, Verizon has been an advocate of fiber to the home since early 2004 or so when we started our FiOS. And whether you believe in fiber to the node or fiber all the way to the home, it's clear that fiber is going to be needed. As you look at things like 5G and getting the bandwidth to those cell sites, fiber is the under base for everything that we're going to do. On top of fiber, we're going to be looking to deliver more bandwidth, more speed at lower latencies to the home. You see a lot of things that are driving this. We've seen an explosion in the number of connected devices in the home. When we started with FiOS, it was maybe 1 or 2. Now we're up into the multiple double digits of devices that are connected at any one time, and that's only going to grow. Latency is also going to be very important for many of the applications that we're going to see, whether it's super high definition bandwidth 8K or whether it's AR, VR. Certainly speed and low latency are going to be very important that we deliver that.
The third area we see is reliability, and you guys heard on my intro, that's one of my focuses at Verizon. And if you think about the historical triple play of voice, video, and broadband, back in history, voice was like the most important thing. People needed to talk to people on voice. And then you had video distribution networks built and video penetrated further. And now then broadband's been growing. So if you think about today and in the future, the real foundational item for the triple play is now broadband. So because the broadband pipe is then you have apps running over the top to do your voice, to do your video, to do whatever, your future services. So making sure that broadband access pipe and then back in the network is reliable is going to be something customers will value, and I think value even more in the future. And then obviously simplification. I mean, you think about simplifying things for the customers, but when I think about simplification from a network standpoint, it's simplifying your architectures, simplifying the amount of devices that you need, making it simple to build, to operate, and to manage. So if you can make your networks simpler to do those three things, it usually drives a better cost structure. And we all know we live in a very competitive environment, so optimizing that cost structure is going to continue to be a focus for us. So that's really what's needed in access. Lee, I think we should tell them a little bit about the leap we're taking technology-wise to help deliver on some of these.
It's a great idea. So we have, we're adopting NGPON 2 as a successor to GPON. We started with BPON, we switched to GPON, and now we believe that the right next step for us is NGPON 2. And some of the fundamental benefits of that are you start with a base of 4 channels or 4 wavelengths as opposed to only 1 on GPON. And what that enables is, one, is a pay-as-you-grow. So on the same pair of fibers, you can add a PON card at a time and continue to add more capacity to that. You don't have to add it all at once, you can add a PON card at a time. Also, with the multiple wavelengths, you have the capability down the road, and we've demonstrated this actually, to do wavelength bonding. So you can move from 10 gig to 20 gig to 30 gig or even more as you bond those 4 wavelengths together. So really good benefits there. The other piece of magic with this platform is what is called tunable optics. And the tunable optics reside in the ONT on the customer's prem, and they let you remotely or even at fault, if the ONT senses a fault, to switch to one of those different channels. So that ONT is capable of tuning to any one of those 4 wavelengths that are available. So if you think about this from a reliability perspective, if a PON card in your CO fails, there's other wavelengths available to that ONT on that same pair of fibers for that ONT to switch to and continue to have service. The other thing is you engineer and you think about capacity and traffic management. If you have one channel that becomes very congested, say, in a busy hour, and you have one customer or a couple customers that are causing that, you have the capability to, on the fly, move those customers to one of the other wavelengths that's not as congested. So from that reliability perspective that we're looking for, you know, a lot of benefits there with the optics that come with NG-PON2.
The other thing that we've done working to implement NG-PON2 is integrate subscriber management. So what I mean by that, in today's architecture, we have a separate gateway router function that's a purpose-built router that is outside of the OLT PON network. Well, with NG-PON2, the subscriber management has been integrated into part of the PON architecture. So we've, back to my simplification, we've eliminated an actual network element. The function still resides there, and the next leap on that function is that subscriber management runs on generic compute. So the generic compute allows you to scale the subscriber management, think about control plane separate from the data plane. And that ties back into like the video where we talked about SDN control and virtualization of network functions. The NG-PON2 platform actually lays the groundwork and is operating that way today. And then when you pull all this together, we feel this really leaps us from a universal access perspective. So if you think about BPON and GPON, primarily that was, from a Verizon perspective, used as a consumer play. We also had some small and medium enterprise businesses, products that we would do on that, but it was primarily consumer. But if you look at all these capabilities with the tunable optics, the 4 wavelengths, the wavelength bonding, this allows you to create a very flexible access network technology that can serve consumers, can serve small, medium business, serve enterprise, serve wireless. So that aspect of the technology we think really serves the market in a much broader base of the market. So when you wrap all this up together, we feel that Verizon's taken a leap here by going into the next gen PON2 architecture. There's some intermittent steps we could have taken, but one of our taglines is, you know, we don't wait for the future, we build the future now. So we feel like by doing NG-PON2, we're really looking at building the future now. So I would like for you guys to really investigate this technology a little further if it has application in your world. And one of our key partners here, Calix, is on the floor. So if you want to go talk to them afterwards, I recommend it. All right?
Thank you.
Thank you.
Our third topic is the evolution of dynamic networks with KA.
KA has 18 years of telecommunications experience and supports the planning, engineering, and project management for teams at ISP, CLAC, OSP, and Network Program Management. KA was previously Senior Director of Transport Network Engineering, supporting Windstream's nationwide network expansion. His prior experience also includes supporting strategic planning, transport engineering, and engineering project management teams at Quest and CenturyLink.
Good morning. The concept of dynamic networks is probably one that you could create your own separate conference around. So in the short time that we have today, we'll try and cover a little bit of the history behind it and what it's left to really today, and kind of finish with a little bit of a call to arms. Now, we'll start off with first talking about a little bit of some of the visionaries. And John Sculley, for those who don't know, is former CEO of Apple Computer, and together with Steve Jobs back in the day, they collaborated with the launch of the Apple Macintosh, arguably changing the face of personal computing. And he said, the future belongs to those who see possibilities before they become obvious. And in much the same way in our network story that goes on, much of the way that our dynamic networks today and the functional networks that are the bedrock of what enables us to do what we do are based off of what the visionaries were able to do back in the day and up to this point. These individuals had the audacity to look further and consider more broadly than the contemporaries of their time. Now, in order to start the story, of course, we need to start with Alexander Graham Bell. And not long after he received his patent for the telephone, he collaborated with his father-in-law, and of course later on they partnered in establishing the American Telephone Company. And his father-in-law was looking to get an advancement to help basically take that invention and commercialize it. And he reached out to a friend of his asking for a $10,000 advancement in exchange for about a 1/6 share of the patent. And his friend, not necessarily understanding all of the technology, but thinking it's kind of interesting, in turn reached out to an acquaintance of his who happened to be the president of Western Union. And the president of Western Union, either not understanding or perhaps understanding exactly what was at stake, replied back essentially that the invention would really never amount to anything, certainly not anything more than a glorified toy. Well, of course, Bell and his father-in-law did get the money that they needed. They started the American Telephone Company, and in fact did well enough that 3 years later, they were able to buy a controlling interest of Western Electric from underneath Western Union. Now, about the same time this happened, another interesting invention occurred in 1881. The copper two-wire twisted strand cable was developed, and of course, that 1881 technology today still carries a lot of the 21st century services and products across our networks at the edge. Also within that same time frame, Bell had another vision that he was looking at and indeed patented, but was never able to bring it to commercial success. And it was what he called the photophone. Basically, it was an optical telephone system. In that same decade, interestingly, over in Vienna, Austria, you had some doctors that began using bent glass rods in order to better illuminate the body cavities of their patients during surgery. They would shine light through those. Fast forward to the 1930s, and you have the first images transmitted through a bundle of optical strands. By the 1950s, Charles Towns and fellow researchers at Cornell University began working on basically light amplification by stimulated emission of radiation. And since that term is such an easy to remember one, they shortened it to laser. Fast forward another 10 years or 20 years, and by the time you get to 1970, Corning has developed the first single mode fiber with the outstanding characteristics by today's standards of 20 decibel loss per kilometer. But within that same time frame, scientists at Bell Labs have gone through and been able to create a semiconductor diode laser that no longer requires refrigeration, but instead can put out a continuous wave at room temperature. Within 5 years of that, the first voice fiber optic conversation occurs commercially in Long Beach, California. And if Bell was still around, he might have argued that his vision for the optical telephone had been realized. By the time we get to the early 1980s, of course, the OSI system that we all know and understand has been codified, and SONET and SDH come in and create a standardization for transport and timing protocol that allows for protocol neutrality for data and better interconnection and easier interconnection across networks. Of course, then by the 1990s, we've got wave division multiplexing in 2000, ROADM deployment, and of course, we know where we are today. About the same time and in parallel to this, and a big part of our story, is the evolution of computers. Now, you can go back to the days of Da Vinci and perhaps even earlier than that and find examples of mechanical computing machines. It's not until 1931 that the first analog computer is created and tested in the labs of MIT. And there are a lot of other concepts that are going around. Array and parallel computing, even though they're not necessarily known by those names, those concepts are beginning to evolve at that time. There's an interesting example of human compute that relates to array and parallel computing that comes into play during the Manhattan Project during the Second World War. The wives and spouses and other technicians of the scientists and engineers at Los Alamos have a lot of data crunching that they need to do. And so they train individuals to do a particular type of computation. And they're arranged in the different buildings at Los Alamos in rows and columns. And if you're one of those people, you receive a number, you perform your calculation, you pass it to the next person who performs their calculation. And by aligning them in arrays, they're able to advance that. Now, of course, In the 1940s, we have vacuum tube technology. It's been around for a little bit, and it's becoming mainstream. It's ending up in radios and of course, the early concepts of the televisions. And it has the ability to begin advancing compute, if not for the 1950s radical invention that is a bedrock, again, for a lot of the things that we have, and that's the resistor chip. The 1960s see the printed circuit board. The integrated circuit chip combines both of those in the 1970s, and of course, miniaturization and manufacturing process lead to the multi-core processors of today. Now, as they kind of begin to come together, we have some interesting things that happen. Of course, fiber technology continues to improve, and in the late 1980s, global undersea cables begin to crisscross the world, and basically overnight, essentially render out of date the copper and coax cables that have been there, and also the satellite technology that was beginning to emerge as a potential communication approach. But there's other Cold War technology that also comes out and becomes mainstream. So there's a couple of different things. It's in this time that we have circuit-based switching that transitions to packet-based switching. Bell's AT&T initially resists it, and of course, we overcome that resistance and we continue down the path of innovation. About that same time, the concept of distributed networking comes out, and that interconnectedness continues to grow with the capability of the networks. ARPANET also has information that now becomes public and, as we know, becomes the basis for the World Wide Web. And that enables even more interconnectedness across our networks than we've ever had in human history. It enables new types of companies, new types of commerce that come out. And then by 1996, if you recall, and you were there to see it and watch it, the very first viral video comes out, forever misusing and abusing that adjective in our lexicon. About the same time, we have the rapid progression and adoption, almost overnight, the mass adoption of cellular voice networks. It grows significantly, and then the advent of the iPhone forever changes mobile computing, and we now have data and voice that are combined together. GPS and social media combine and enable more and more capabilities than we've had before. And so at the same time that we're going on, there's also the prognosticators, much like the president of Western Union back there, that offering helpful or perhaps not so helpful insights on the way that the networks and the technologies may evolve and support us today. But an interesting thing's going on through all of this. We still have the visionaries doing the things going back to Bell's time or Da Vinci's time. But what's changing is the cycle of innovation is radically compressing with the ability of more interconnectedness. It leads to more and more data and more evolution. A recent Forbes article had noted that 90% of all data in human history was created in the last year. The ability to manage all of the data in our networks and our computers arguably has exceeded human capacity, despite the scripts and the programs and the apps and the tools that we build. And so we still need to do better. An interesting Salesforce survey of high-performing companies had noted that 86% of companies believe that they compete primarily or exclusively based on customer experience. And so for those of us that provide the networks, these advanced networks, that provides a new challenge for us. First and foremost, in order to be able to compete, each customer and their needs for their customers requires specificity. It requires commitment and service delivery expectation, that consistency that comes in, and it requires agility. In order to do that, we need a foundation on which we can begin to innovate and find new ways of introducing products quickly and tailoring them to the needs of our customers. It also means that machine learning becomes a key component of the way that the networks run. We need the ability to understand what our customers are doing and the behaviors that they're taking so that we can anticipate what their next need is and ensure that the network is available and that the services that they require are ready at the moment that they begin to do them. And so within that, it takes us down a different path of skills and knowledge that's necessary to support these new dynamic networks. In a Harvard Business Review survey of large company execs, nearly 40% said they struggled to find the needed technical talent to fill open positions within their companies and continue to innovate and advance. Another survey of European and North American business leaders found that 1 in 3 of us may need to adjust our skill sets in the next less than 12 years, actually, in order to remain relevant and continue to support productively in our companies. The technological skill sets needs will increase by another 55% in this 12-year period. And as AI and machine learning and these types of programming skill sets and new technologies come out, they're supplanting some of the traditional industries that are out there as well. Take, for example, when you go to the airport today and you check in at the kiosk, you're interacting with a kiosk versus the person that used to do it. Same thing when you go out to McDonald's or Wendy's, you're getting the kiosk there. You've got your Starbucks app on your phone that allows you to go in and order things and even anticipate based on your ordering history. And when you're calling a help desk or you're instant messaging with a help desk, you're interacting with a bot that is carrying through the early part of the conversation. And coming to a screen near you soon is a virtual reality person that you may be interacting with. And so as we go through those types of changes, it changes also some of the other base industries that are out there. We now have cab companies that no longer have their own cars, but instead run apps, hotels without their own buildings. You've got GPS-enabled vehicles that run on our farms, that are currently driving on our streets, and very soon trucking companies that will be carrying goods and services between warehouses and the store that you go to, and perhaps even to your own place. So within that, it also highlights the need for a new and unique set of skills that hasn't really had as much focus in the past. And so by 2030, we need employees that have the skill sets that are higher for initiative, complex problem solving, leadership, and creativity. What's interesting when we look at all of this, there's another stat that we have to consider. Today, or very soon, there will be as many people retiring out of the workforce, and actually more so than those that are entering the workforce. And those who don't retire or delay retirement are going to end up working longer than they have up to this point in our history. So with these pressures on the side, we have a couple of things that we need to look at. To borrow the words and the quote from physicist Richard Feynman, I think this has some significance to our problem. So I'll leave you with kind of the call to arms that I mentioned before. With this knowledge and understanding the rapid advancement and evolution within our networks, we have to decide if we're prepared and committed as individuals, as companies, and as industries to invest in the learning and the potential to raise our current workforce in order to meet those future needs. Remember, the future belongs to those who can see opportunity before it becomes obvious. Thank you.
These tech talks were definitely intriguing. Thank you so much. You all did a great job. Now it's time for us to take your questions, and you have been texting me some. In fact, they're coming in right now as well. So I'm going to pose them to the panelists, and they will have the option to say pass, but they're so smart, they'll know everything. So let's start with Ken. To Ken. That is your name. Sorry about that. Big data allows optimization during design and first install. What else can be done for layer 1 optical fiber infrastructure to better accommodate future scaling of fiber needs and high demand deployments such as smart cities? A living and future-proofed network? How?
Well, that's a very interesting question because it brings, in my opinion, brings kind of what the gist of my talk was together, because there needs to be a continual cycle of innovation in the physical, the actual construction, how we piece together the fiber infrastructure and how that ultimately ends up getting built. And I view that the big data structure is actually going to help fuel that so that it can crystallize the decisions that need to be made in a very precise way, almost down to a per neighborhood way, so that at any given point in time, you know that you've deployed the optimal network. And as much as, if I go back 5 or 6 years ago, we would kind of wave our hands around and say, well, it's pretty optimized, but, how would you actually prove that? And I think, that ability to capture the real world in a data model is pretty fundamental to where this is all going next. And so, if you're talking about starting out with a LiDAR image and literally moving it to almost virtually building it before the crews even arrived to that neighborhood. That's a huge deal, and I think that it's not just one area. It's the cross section of all of the areas that we're used to dealing with that are going to end up going through that change.
Thank you so much. I'm getting lots of questions. All of you, how are you helping your teams learn to be adaptable and evolve to the next level for your company's needs, besides ISE Magazine and ISE EXPO?
I'll start. So we have actually, individuals that we've kind of knighted, if you will, to help us make that journey. In particular, agile and being more agile and sort of, because it's not something that comes obvious and easy to people. So we've actually sort of have people that's their job. It's become their job to help us, folks like Brian and myself, but everybody on our team make that change. And we think it starts at the top, and so we've been trying to lead that.
Good position.
I'll jump in. So for Windstream, we started a program within our transport engineering group about a year ago, and it's basically a skills assessment that we've done with all of our talent to really understand who has what knowledge, right? There's still a lot of the legacy network out there that you need that knowledge set that's there in addition to the new technologies that we're moving toward and as things go in. And so understanding that, number one, gives each manager, as well as the others on the team, the understanding of who has that skill set, a little bit like Lee was talking about. And it does two things. Number one, it allows us, when you're looking for a SME, and we ask people to rate their knowledge as well, are you just kind of acquiring the knowledge, or is this something that you've done forever and ever and you can do in your sleep and walking backwards while you're chewing gum? And so understanding where that is, it helps identify more of the SMEs that otherwise has just been kind of tribal knowledge up to that point, but it also exposes where we have the knowledge gaps so we can tailor our training to be able to go forward in that. And we leverage a variety of things. We've got some great vendors that we're able to team with that come in and help us with certain focus area. And then through our training organization within our HR department, we focus training on that. But beyond that, and even to the topic that I was talking about, we are starting the early stages and we're going through the conversations to really understand what are the skill sets that we need 1, 2, 3, and 5 years further out so that we can tailor and understand what we need from a training perspective to make sure that we have the right knowledge sets at the right time in the workforce.
Great input. And then I have to add a shameless plug. KA reached out to us several years ago and said, based on our findings, we would like to create some custom private events that help educate our teams. And those have been very successful.
They have.
We've been working together on that. So if you have those needs, we're here for you. Ken, did you want to?
Well, I'll try to be really brief, which is hard for me, but I think, to me it starts with the executive vision of what problems are we trying to solve as a company. So that's number one. And then number two, we actually found a lot of success in hiring a lot of interns right out of school. And while, a lot of times they have problems with kind of day-to-day stuff that we take for granted, from a technology perspective, they are absolutely fearless and they're not carrying around, a deep-seated knowledge of the legacy network, so to speak, that could get in their way. But the important thing is to mix those with really experienced people so that you got to let everybody be where they're at, and then they will learn from one another, and at the same time, the more experienced people will then start to realize, well, I'm weak in this area and I need to shore myself up in this area. So as an executive, I can't remember the last time I turned down a training request. So that's what you have to do. But that training has to come from within, from my perspective. You can't just like nail that on people and say, well, you got to go have this and this and this. Yep. So we have to be really entrepreneurial, all of us.
Agreed.
So.
And Peter Pohl told me a lot of years ago, he said there's a reason it's called professional development, because you're a professional and you're in charge of your own development. So you have to be hungry. Let's go back to the technology questions. Lee and Brian, do tunable optics at the ONT integrate with other IoT-empowered devices? Switching wavelengths is powerful for service reliability, but is there a lack of insight into power, the back end of reliability?
Yeah, I guess to take the IoT part of it and integrating, right now, I mean, we're not integrating the LAN part of the service into our ONTs. We have the capability to do that down the road, but we're kind of keeping a separate home gateway in our architecture. And that, of course, will have all of the IoT functions that will be part of it, along with the Wi-Fi and the management that we do, but it'll also support all the IoT that we need. Obviously, from an upstream bandwidth perspective, PON is, very good at that. It's superior to any of the other technologies that are out there in terms of delivering the upstream speed that we think we're going to need for IoT. And I guess on the power question, could you, I'm not sure I followed the power question, could you?
I apologize, I just whizzed through that. Let me go find it again.
That's all right. We pass on the power question.
We passed on it. Well, how about this? We need power.
Yeah.
Yeah.
Yeah, it needs power.
Okay, there you go.
I'm waiting for that day when we invent stuff that does not need power.
Yeah, I mean, if the person who had the question wants to check
catch
with
us
us afterwards,
afterwards.
we'd be happy to talk to you about that.
Great. Thank you very much. KA. How will the end of net neutrality affect the IoT and the continued advancement of the connected world? That's a simple one-word answer, isn't it?
I don't know. That's a great question. I think we'd all like to kind of understand what that looks like at the end of the day. I think net neutrality and the way that it ties in, again, I think most of those things for a lot of the connectedness, I don't know that it plays the biggest role because typically you've got service through whoever your service provider would be, and that your devices are being connected through that. I think most of the IoT devices are very, very low bandwidth. So it's not like you're looking at something that you're going to overwhelm the network individually. Now through the sheer number of devices, yeah, I think that's where we're going to see potentially those same impacts like we've seen with video on maybe the core of the network, but as an individual consumer, I don't know that necessarily plays a role.
Anybody want to jump in? Lee? No.
I mean, when I think about IoT devices, my first thought goes to the security aspect of it, because as you get more and more out in the network, you just have to make sure that the security is integrated into all those solutions from day one.
Here. Ken, do you want to add on or no?
Well, I think we oftentimes underestimate, so people that think that net neutrality is somewhat resolved because now, we've got an FCC direction. It's kind of not really happening that way because now instead of federal regulation, we're seeing it pop up in all the states with basically the old view of what net neutrality was. So ultimately the industries, meaning the over-the-top guys and the network providers, are going to have to solve this problem. And it's not, the current state is it's going to languish there. And so I think we're going to see a lot more action in that in the next couple of years than people think.
I tend to think competition will solve it.
Yeah.
Right. I mean, we're seeing that already, and I think that
would be
continue
nice
to be the most important driver to keep us all doing the right thing.
Good input. Here's a question to all of you. How many more years do you see the legacy network will be around?
5 to 10. At Verizon, anyway. We have a pretty aggressive program to switch everything to our IEN network that we're building now, and that will 250,000 network elements are coming out. So next 5 to 10 years.
Cool.
Yeah, I'd say if I had to guess from a Windstream perspective, probably on the longer end than what Lee had mentioned. It's a balance from an economics perspective in terms of what you're trying to cut over and everything, and of course, the FCC uni ruling and those kind of things may accelerate a little bit of it, and the adoption of new technologies will also help accelerate it too. So as consumers and customers adopt the next gen product sets out there, that will help remove a lot of those old TDM services out there and then enable us to, whether you're actively pulling it out of the network or retiring it in place, depending on your space and power needs, will enable you to kind of take that action. But I would agree, I'd say a little bit further out on that, for us at least, I would presume about the 10 years.
I mean, we have a solid business case,
Yeah.
Built around simplifying operations, reducing power, and having better cost per bit. kind of like our financial people have stopped asking, what are you doing, and started saying, why can't you go faster, right? Which is a good thing, right?
Great point. Ken, do you want to?
Yeah, I would say that, we're kind of already running the legacy network and the to-be network simultaneously is the way I kind of view it. And the customers are really moving there based on the products that they're choosing. And so as every year that amount of the customer mix that relies on the legacy network goes down and down, it's hard to predict when the light switch will actually go off. But I can tell you that it becomes more and more irrelevant every year. And so from a product perspective, if it's irrelevant, then you get right to what Lee said. Then it's all about, hey, can I save $1 here by taking that out, or, and so I think 5 to 10 is, I would be, well, I always am overly optimistic, but I would say I'm more on the 5-year part of that, just because I think customers are really moving rapidly to the new products.
That could help accelerate it. Yeah.
Yep.
Good point. We have one more question, time for one more question. If there's one thing you'd like from the suppliers in our community to help you all with, what would it be?
I'll start. And everybody that I talk to, I tell them the same thing, but help us simplify and speed up the installation of fiber. Whether it's tools, materials, procedures, the way you make things, multi-fiber connectors, whatever. Anything, we're open to the innovation that you've delivered in the past, and we need you to continue to do that to help us.
And I would second the innovation cycle part of that. There's a lot of open highway to building more and more fiber, but we have to fix the economics in a lot of ways, and I don't want to just fix them. I mean, it would be okay if we could fix them by just pounding you on the head and say lower prices, but realistically, that's not a long-term solution either. So the only way you really get there is by innovating new architectural solutions that end up being cheaper and fit the economic model better. Because if we can get fiber down, 25% cheaper than what we got today, there's probably a lot more that we can do. I mean, I spend a lot of time, obviously, with people that have the money to invest in these kinds of networks, and I'm telling you, there are no stop signs for them other than, well, we're not going to spend that on a per household basis. So if we keep bringing more households in under those thresholds, then we can keep building.
I'd just add in, when I talk to people, I always ask, look at it from a total cost of ownership from our perspective. So instead of looking at up front or back end, bring it all together. Because when we put something in our network, we expect it's going to be in there and running reliably for a long time. And we want to understand that full cost. And it gets a little bit back to what you're saying. Once you know that total cost of ownership, then you know your not only your upfront cost per new subscriber, but what's that ongoing care and feeding, and how you can understand that and drive it down.
Yep. Yeah. Hard to add to what all three have added in here already, but it is the economics, plain and simple. It's understanding that and taking the time, right? And I think, maybe a little bit more openness sometimes between us, and if you're a vendor, we need to perhaps share a little bit more information, but we also need some of the sharing to come back so we can have those free and open discussions about really what we're trying to do so that we can be successful together.
Which is why, shameless plug, ISE EXPO is here, because that's where you can have those dialogues and begin to problem solve. With that, I would like to thank our presenters. Thank you so much.